The common bond between the two speakers are that they are both hardcore hackers. Interesting, right? All right, please welcome the CXO of Cloudant, Sam Bisbee, as well as an engineer from Nodejitsu, Jarrett Cruger.
Thank you all. I very much appreciate it. So I am Jarrett Cruger from Nodejitsu, and we'll start off here. So get here. Can you guys hear in the back? No. All right. Anything? A little louder. All right. I'll try to keep it close. All right. So Node.js applications, from real time to the cloud to like any kind of like enterprise infrastructure. Like Nodejitsu, like we built our whole infrastructure on top of Node. Like every piece of software we write is either in C or Node.js. So this is an assumption that we make that JavaScript is actually going to be going places. You guys might not agree, but that's my assumption. So why should you use Node.js for your next application? First, it's always been on JavaScript. Now this is a fun little anecdote that was said by Benari, who's the father of JavaScript. Who, like over the course of the years, people doubted JavaScript. They're like, oh, it can't do X, it can't do Y, it can't do Z. And last year in his state of JavaScript talk, he had one slide that was like, oh, yep, we did all of those things that you were doubting. So that's pretty much it. Like JavaScript has survived. Has survived for what? What is it now? Like 18, like 20 years almost.
So is it the new C?
Not quite the new C, but I think it's doing good things for the web. But so if you are already using JavaScript, or chances are you are using JavaScript for your front end anyway. So our argument is that why not use it on the back? Like it provides for like optimizing for code reusability and well, enough said. So also in like Node.js, it is really hard to write slow programs. Like if you're using like things such as like Ruby, like Python, and things of this nature, it is not asynchronous by default. Like most applications are actually bound by like network I/O. So you end up spending too much time just like waiting to get data back from your database than you do actually process it. So you might as well like be doing something in that time. Like for example, like Apache, I believe how Apache works, that it forks a process for each like request that you receive. I mean, like that's all fine and dandy. Like that's the mechanism it uses to, I guess, not block. But like Node is able to handle like a much higher throughput with only a single process because of its evented and asynchronous nature. So another, like why Node.js? And like soft real time is simple. And what I mean by soft is it's not, I guess, you're not dealing with like life or death kind of situations, or where like it's necessary that like you receive data in real time. So like soft real time, that people are mildly inconvenienced if they don't receive it like in real time. But I haven't seen it fail too much. But yeah, real time in Node.js is simple. It just works. Like it's kind of built like that. That was the, I guess, big appeal point for a lot of people with Node, is that you could just like throw up a WebSocket server and start using like these new technologies very easily. And then from there, like new protocols were built to like optimize for this real time, where like things like Engine.io or Socket.io. Like this allowed you to use both JSON-P, like JSON polling, like XHR, and still have the same type of real-time connection. So this made like compatibility across browsers like happen. And so some soft real-time systems, as you can see, is like activity streams, like Stocker newsfeed, any kind of app like chat application, or anytime you want multiple people working on the same, like collaborating on like a document, something like that. Like you could say like Google Docs. makes it easy to write applications of that nature. And the biggest part for me is like it's modular by default. And this will be a common theme throughout my section here. Is that like Node.js modules, which is powered by like npm, essentially offer all the functionality that you might need are like you will find in these modules. And if like one module does not happen to exist, like it's pretty trivial to write. So like that's like one of Node's biggest, I guess, biggest advantages is the ecosystem it has cultivated over the last few years, and it has promoted this concept of innovation through modularity, which I will get into. So as you can see, a single Node.js application only depends on more than a dozen modules, and like this is not a bad thing. This actually makes it more explicit, like for what your application needs. So like you don't require like some huge library in order to, I guess, provide most of the functionality for your application. You're able to find like the discrete functions or discrete pieces of software that you need, like from npm, and easily, I guess, integrate them in your application. So, like, why? Like, we're here from Nodejitsu Cloudant, so why us? And first point, Node.js is built for NoSQL. So, many NoSQL databases, including like Cloudant, which uses big cache based on CacheDB, or MongoDB, return JSON. And by using like JavaScript, you avoid any of the hassle of using any kind of esoteric JSON serializer. And if you come from a Ruby background, like you might be familiar with like how hairy this can get. Like which one do I choose? And co-located databases. So Nodejitsu Cloudant, like we both run on top of Join, and like Join has treated us well and has, I think, gotten like the highest performance that I've seen out of a cloud provider. And like the advantage of, I guess, using both of us is that we will give you much higher throughput on any of your data, like any of your application. If you're just hammering your application, inserting data, like it will not falter due to like network failures. And also, one thing I want to mention is like we are both experts in like distribution or like writing distributed software, essentially. Like Cloudant's big cache built on top of CacheDB is like multi-tenant, like by default. So they have distributed built in, and like at Nodejitsu, like we've architected our whole cloud like under the same assumption. So like growing your application. So like you're building this Node application, and you won't like, and it's starting to gain some traction. Like you have a few developers. You start to hire a little more, and like the question comes like, do you need an ops team? Like, do you need that extra overhead of having people manage your servers? And this is really where like the database as a service and platform as a service comes into play. Like, if you don't want to have to deal with that, and you want to optimize for hiring more developers in order to extend your applications, then that's a choice you'll have to make. But this is where we kind of fit into things. As you can see, like growing your developer team like this, you can run into like diminishing returns when like working on like large applications. And there's actually a way to solve this that I think Node does very well, and we will revisit this concept of innovation through modularity. So the one key point about Node is that there is no standard library. The core of Node.js is very, very lean. It only provides like the very basic protocols like HTTP, TCP, file system interaction, like spawning child processes, like anything you want to do on a system at like the core level, it provides all the basics. But any kind of functionality on top of that is not built into the JavaScript language, that is where the module ecosystem comes into play. And like I guess the big thing about this is that the ownership of these modules comes into play, where it fulfills like the satisfaction for developers that you don't really get contributing to larger code bases. Like the sense of ownership is really powerful. Or like the other day, I was able to like published a little module that did like exponential backoff, just like a simple function that handles that. And you know, it's empowering that like I can just publish that out there for anyone to use, and it's with a very simple interface. It helps foster this kind of innovation because people are a very important element when it comes to building software. So if you're not familiar with Node, like let's go like what are Node modules? So as I mentioned, they're like very like we like to have them as very small pieces of code and reusable. And like that's why you have the whole process. Like developer just creates a piece of functionality, publishes up to npm, and now you can seamlessly install that into your application. The mechanism that I guess was come up with is this module.exports equals function. This is the kind of the idea is that you want a very simple interface for your module. You only want it to do one thing, like solve one little problem. And if you already are familiar with Node, then you probably use modules such as express or request. And like these are just some of the popular modules that exist. So I've talked about this npm thing, and this is where all the modules live. npm loves CouchDB. This is, I guess, where the NoSQL comes into play. And so npm is responsible for managing all of your Node.js dependencies. So npm comes in two parts. There's the CouchDB database that handles everything, and the little CLI client. The little CLI client allows you to just npm install any module, and like then that's it. Like Couch handles the magic for you and sends you down a tar hole. And npm is already bundled with Node, so if you install Node on your computer, then you're already set to go. You can install any module and start creating your application. So this is a little bit of the growth rate that's been happening in the Node ecosystem over the past couple of years. And as you can see, it's increased over 300% in the last year, and it's only growing from there. And it all stems from that idea of like ownership. Like developers are just publishing out modules, breaking their like what would be libraries into smaller components that they piece together. And this allows just more reusability, and it allows other people to innovate on top of those smaller modules. As you can see, it's actually growing twice as fast as like any other ecosystem on the market. So, like if you want to get into like if you're writing software, you want to be where like the most developers are providing value, and currently that is good. So that's why I'm glad I'm in the position that I'm in currently. Now we'll talk a little bit about like what is a private npm registry. So like on this point of innovation through modularity, if you want to, I guess, have this happen at your own company, you want to enable your developers to like take ownership over smaller pieces of software so that it's more scalable. Because if you have like 30 developers working on one big project, that's going to get messy real fast. And this is something that we provide. It allows custom replication from the public npm, so you can even filter out any modules that, like you could filter out any modules that you don't need. So this allows for, I guess, better security management over your modules. As well as now your developers can publish to your private npm, and npm is already very good at being a distribution mechanism. So why should you use private npm? I kind of talked a little bit about this already, but yeah, you can publish private modules. You now have a central repository where all those dependencies are managed, and this can be installed either in your own infrastructure or on any infrastructure as a service provider. And as I mentioned, only replicate what you use. So this prevents any kind of security issues, and you already have all the modules that you might need in your private registry. So if anyone is interested in this, you can email sales@nodejitsu.com or come talk to me after the presentation. Now I would like to introduce or bring up Sam Bisbee to kind of finish off.
Hey everybody, I'm Sam Bisbee. I work at Cloudant. Yeah, that's me. So, just want to level set for a moment. I only noticed this morning that this is actually a MySQL meetup technically. Raise your hand if you've ever used NoSQL. Wow, that's actually pretty good for a MySQL meetup. All right, cool. So I do this talk on a regular basis. There's many different variations on it. Feel free to ask me questions as we go through. This is the abbreviated version. And in this talk, we're going to be focusing on operational data stores. So the layer where you put your MySQL, where you put your Mongo, whatever. We're not talking about data warehouses. That's because data warehouses are bad. Generally speaking, in the 90s, we didn't really have full confidence in how to scale our production database systems. It's always been a problem, especially coming through the dot-com boom. And so we built this artificial barrier between what we decided we could store and analyze offline and what we need online for our users' experience. But now today, we've kind of grown up as an industry, and we can scale our production database systems well/better, and you're able to do more and more of that offline cranking out online in your production database system. This also kind of just brings down that artificial barrier between your users and all that data that's sitting in there. But unfortunately, to really have a intelligent conversation about this, we need to jump into a time machine back to 1870 to get a little bit of context. Back in 1870, modern set theory became a thing. And in 1970, COD, just because we were doing trivia earlier, who knows where COD was working? IBM? Yeah, IBM Labs. He wrote a white paper basically taking this mathematical theory and applying it to, hey, we've got like electronics now, we've got networks, how can we start to use these things and use this math system to store our business data and analyze it? Those basic fundamental ideas that Cobb published in that white paper would later become your MySQL, your SQL, etc. And since then, there was all these different implementations of his idea on relational algebra. Relational algebra being the formula system in which you query in set theory. It's became your SQL. Being from Boston, if there was one thing we were good at in the 90s, it was producing SQL and database startups. And so you just saw this boom of all this work. From 1970 to around 2000, really, it's not that there wasn't innovation, it's just that there was innovation in a certain applied vertical of Codd's ideas, of database theory, etc. That was okay because we weren't really, there was nothing wrong with it. There was no reason to do something else. Well, in the late 90s, a reason called the internet became a thing. And that was really this watershed moment for a lot of different pieces of technology, especially for databases. A lot of the really big companies or big logos that you think about lasting through the dot-com boom, they had to go build their own database tech. They had to go and hire the mind-blowing computer scientists, etc., and go figure out how to solve these problems in different ways. Luckily, post-2000, a lot of those companies have gone back and written white papers, not giving us implementation, but generally telling us how they solve these problems. And there's really four, if you can have four cornerstones, there's four cornerstone white papers. Does anyone want to yell out what any of those were?
Triangle.
All right, well, yeah. Sure. Anything else? So the four that I like to list off are Google MapReduce, Google File System, Google Bin Table, and does anyone just want to take a swipe at the last fourth one? I'll give you a hint, it has to do with Cloudant and a book company. Amazon Dynamo. And really, so Hadoop, the Apache Hadoop project was basically a group of folks getting together and saying, at a very kind of hand-wavy level, we're going to go implement these Google white papers, essentially verbatim, in an open source project. They're really cool, let's go see what we can do with them. And Hadoop's done very well in that area. Hadoop's also just kind of turned into a data warehousing tool. But the reason why I want to bring up this historical context is it's not that SQL is bad, it's not that Cod's work was bad inherently. Like at the end of the day, there's nothing wrong with MySQL inherently. It's just that we're trying to solve different problems that MySQL, Mongo, etc. aren't necessarily good fits for, right? Especially now that we're going through kind of another watershed event where, back then the internet became a thing, and holy crap, we don't know how to scale for that. Now mobile's a thing, we don't really know how to scale for that. We've got all these technology has become more and more commoditized, so now it's actually reasonable for hundreds of thousands of people to go write mobile applications. A certain percentage of them are going to become real and have to scale, and they might not have engineering backgrounds, right? And so we're starting to hit these new and interesting problem sets. And so that's why I like to kind of walk through this timeline. Also because most people don't really know the history of where this comes from. Yeah, so what is NoSQL? I basically just reviewed this, but the thing I really want to call out is not just about data volume. People are always talking about big data and how it links with NoSQL and how they came out hand in hand. Well, first of all, let's just level set. Big data is a bullshit marketing term. Basically, GigaOM needed a label to use, Forrester needed a label to use. They decided to use big data because price per gig and hard drive has plummeted. So you had all these CIOs walking around thinking, I don't have to throw out data anymore. And the promise of big data became, well, once you combine your big data with your NoSQL, the Oracle of Delphi is going to rise up out of your data store. You're going to have all these insights into your data. And there's enough smiles up here that everybody knows that that's crap. But the key is it's not just data size, right? It's concurrent connections. Again, the problem with the internet wasn't that we had all this new data, it was we've got all these new users. This is again happening with mobile, but just also as people try and use technology more, bigger and bigger demands are being placed on it, even with the same population. So the next question that people kind of ask me is, what's wrong with rows and columns? Right? There's nothing inherently wrong, except there's a two-dimensional structure. I can't remember the last time I built an app. I can't even build a guest book application in a demo without going past 2 dimensions, right? We're taught, third normal form and all of these tools. It's not that, we wake up every day going, hey, I can't wait to, write some third normal form queries and data structures. It's not a fun, good thing. It was just what we had to do because we were in the system. It's also not optimized for how humans think about data in their brains. Kind of one of my favorite examples, and I'm stealing this from several people, but I'll claim it as my own, is if you look at business cards, right? If you look at a sales guy's business card versus my business card, sales guy's business card is going to have his name, company, and 10 different ways to send him a PO, right? If you look at my business card, it's going to have my name and my email. That's it. That inherent schemaless nature is what we see generally in the physical world. We're not carrying around, on my business card it doesn't say phone, no, mobile phone, 0. That's just not how we think about data. And so our data stores are now starting to become more and more human friendly. And let's also clear up one misconception. When data stores like Mongo or Couch or Cloudant, when we say that we're schemaless, that's a misnomer. We should just, as a community, decide to stop saying schemaless because that's crap. You're not querying your data with chaos theory, right? Your data does have an inherent schema in it, it's just not enforced, right? And so when you look at a storage engine like Cloudant, it's not enforced schema. You can put multiple dimensions of data into one record and have all of it addressable and indexable by that platform or that engine for you. You're not forced to kind of normalize your data. For example, let's say a write request comes into your app tier, right? And it's got some complex business object. If you're using a MySQL or whatever, you're going to have to break that object apart and store it in all these different tables and all these different locations. Right? That's your write transaction. Then on your read transaction, when it's coming back out, you got to do these complex queries to pull it all back together and then send that back out. That's not really optimal. Why not just, if possible, just store that thing by itself? Yes, you have a question. The question was, am I suggesting dynamic typing for databases? And it's not precisely that, but I think that's a good analogy to draw. You coming out of the C, C++, Java world, and then PHP and Ruby and Node.js, all these guys came out. Yeah, you can iterate a lot faster. When your schema is not enforced, you can just go iterate against your database, and you don't have to go through 10 minutes of red tape trying to figure out, well, what did the other developer do? How do we roll out these schema changes? No, fuck it. I just send the data, and it just goes in. It's just accepted. I put the validation to that app here. So why not repurpose SQL? There's actually a couple companies out there trying to, how do we get SQL to go on top of Mongo, whatever? One of them was Couchbase. That was a company that tried to create a spec called Uncle, unstructured query language. The funny thing about that was you're writing SQL is like select whatever from whatever, where, and then there's like a JavaScript function. It was kind of weird. And the problem that they ran into, which pretty much everybody else runs into, is we threw away set theory. Going back to that one of the first slides, we threw away that set theory. We threw away a lot of COD's general foundation, so we're not allowed to use relational algebra anymore. That's all a SQL is. It's just relational algebra. Now we're trying to find new and interesting ways, whether that be MapReduce, for us it's incremental MapReduce and some other engines. We're trying to find new ways to go and query the data. That being said, one thing that Cloudant does not do well, or Couch does not do well, is ad hoc queries. Right? We tend to have everything kind of purely be pre-computed, and we don't have we don't really have a DSL, right? So that's something that we're working on because a lot of people have asked for that. But we've had plenty of people launch large-scale applications across global networks on what we had. So what that tells me is that there's nothing inherently wrong with MapReduce or any of these harder to understand things. It's just that everybody learns SQL and it's harder to change their mindset. Yeah, so as you can tell, this isn't really like a go rah-rah Cloudant deck. This is like NoSQL. So I used to do consulting, and people used to always ask me, what database should I use? I'm not actually going to answer that question for you, but it really comes down to starting with the questions that you want to ask. Normally people, when they're picking a technology, they say, all right, I want to populate this UI and my team's got this general knowledge, and so they're starting with the answers that they expect to get out of it. More and more we're seeing that starting with kind of what kinds of questions what kind of queries do you want to run? Are you going to do geospatial? Do you need to put things in there with a key space that's larger than what you've got available in RAM? If so, don't use Mongo. But also, does all your data fit in RAM? If all your data fits in RAM, you do not have a problem with scalability. You can solve that with not a lot of money, right? AWS, I built this deck about a year ago, but at the time, AWS's largest instance was a CR1 8XL, 244 gigs of RAM. You're telling me you can't buy one or two of those and solve your scale problems when you've got 10 gigs of data? You're crazy, right? But these last two bullet points are where people tend to get really tripped up. What are your consistency and durability needs? And do you want to scale horizontally or vertically? Right? Because to truly answer these questions, you have to understand some basic database 101 theory type stuff. All right? And with that, I'm going to do the obligatory NoSQL conversation thing and go into the cap theorem. Because everybody needs to have a different opinion about cap theorem is. Who here doesn't know what the cap theorem is? It's okay, just raise your hand. Awesome, that's even better. You get to learn my version. So, generally speaking, CAP stands for consistency, availability, and partition tolerance. your database is only allowed to have 2 of those. You're not allowed to have all 3. Your MySQL, your Mongo, some of your flavors of Hadoop, whatever, they all go for consistency and availability. Right? So when we say consistency, what we mean is if I do a write in this data center or on this server, that write is going to be showing up on this other environment in that same state. Right? It's not that people like master-slave architectures when they scale their databases. It's that their consistency requirements say, I need to do all my writes here, and I have this one point for my writes, and then they're going to go up and they're going to spread out. That's the general consistency point. Availability is generally what you expect it to be, that somebody's going to pick up the phone on the other end of your database connection. And partition tolerance is, can 2 servers not know about each other but still do work? Right? So if there's a net split between your data centers, if a server goes offline, if any of these perfectly common and acceptable things happen, is your database still able to do both read and write transactions? Right? And let's be very clear, things break all the time. At any given moment, a large percentage of the links in the internet are down. That's why we have many telco providers out there, right? So net splits, servers going down, all this happens on a regular basis, yes?
For partition tolerance, we talked about like the database equivalent of a RAID array.
The question was, for partition tolerance, are we talking about the equivalent of a RAID array? No. And I only say no because I don't fully understand technology. It's more of like, if I've got 2 data centers, right? Think about your master-slave architecture, right? You've got all your masters in Ashburn, taking all your writes.
I guess what I wanted to know is each one of those partitions able to recreate the missing component?
Yeah, so they're all able to recreate the missing component, yes. But for tech like Cloudant, we can get back to that consistent place, but eventually, right? It's eventually consistent, right? And so, in a world where hardware breaks, where network links go down, where it is now trivial for you to stand up your app stack or your mobile stack or whatever you want to call it in multiple data centers, this problem of dealing with multi-geo is a very real one. And most people do have to put all their masters in one data center, do the log shipping to another data center, maintain those links, etc. That's a horrible experience for operators having to maintain that. That's a horrible experience because you've still got a single point of failure. Raise your hand if you know what the single point of failure is in a master-slave system. Yes, sir.
Shall I explain?
I just say what it is.
Oh, so when one thing goes down, the whole thing basically doesn't work anymore.
Yeah, and specifically on writes, right?
Yeah.
Those masters where you can send those writes. Even if you do the MongoDB thing of standing up, you've got all these different shards, and each shard has its own master and then a bunch of slaves. That's great. That shard still has a single point of failure on that master. Mongo then says, well, we've got this election system, so if it goes down, another master will pop up. I've never actually seen somebody happy with Mongo's ability to perform that. Mongo also, /Tangent, did this very weird thing of they decided to build their own election system because like Zookeeper, Paxos, like all these kind of things apparently weren't cool enough. So my general point here is failure happens. Anybody who's ever built a distributed system before knows that failure happens. You need to build to handle that. You're probably trying to scale across multiple data centers. You need to embrace eventual consistency. Whether you use Cloudant or not, you need to embrace eventual consistency in your data models. Financial networks did this a long fucking time ago, and they're doing fine, right? If I go swipe my credit card downstairs right now, and then I go onto my bank's website, I'm probably not going to see the transaction there. That's why checking accounts have this thing called overdraft charges. They have built into their system the ability for people to spend more money than they have even on their checking account. I mean, credit cards are based on this entire concept, except they really make money off of you. But with the debit card system, like that's core money. That's not. That's something that people are like. Of course, I want hard consistency on that. No, you don't. It's okay. Embrace the eventual consistency, and this will be a lot easier if you start modeling your data as transactions instead of objects or nouns, which I can talk about after this because it's probably. I'm actually not right away, but come find me afterwards if you talk about it. All right, so durability. This is the next one, and this is also one of my favorite slides to do in New York City because everybody, for some reason, in New York City, well, I know the reason, but everybody loves Mongo, and Mongo is probably the least durable database, actually the second least durable database that I know of. The most undurable one is Couchbase, because in Couchbase you truly never know what state your data is in. It's a very scary proposition. So for some people, this first question of can you lose data, some people can say yes to that. That's perfectly okay. I can, if a user hasn't logged onto my system and my system is a mobile app or a game, and they haven't played my game in a year, yeah, I can lose their data. I don't really care about that. Or, Facebook and, did you poke somebody? Yeah, you can lose the fact that, that they didn't get poked. So if you can lose data, that's great. Write it to RAN, you're going to get awesome write-through. Cloudant errors / CouchDB errors on the exact opposite end of the spectrum. We are probably one of the more durable solutions to a fault where every single write that you do to us, we do an fsync. For those who do not take an operating systems class, an fsync is basically a kernel level call where you say, take this data and only report a successful write when the hard drive has acknowledged that it's on the platter. Now, hard drive acknowledges that it's on the platter as a relative term when you start talking about certain RAID card vendors, but it's there. The operating system, as far as it's concerned, it's on the disk. We also do a tail append only system. So we're not going to the middle of your database file and changing stuff. We only write to the end of it. And so this means when we stop our service, when we stop our database, if you look into our init script, it just does a kill-9. For those who don't do Linux, we basically pull the power cord on the server, right? It's fine. It just crashes the thing. We don't care. Because when we come back up, all the writes that we did, that we told the user were successful, those are on the platter, the tail append only format. We can just go and rebuild. Perfectly cool. This gets a little trickier when you start talking about the fact that we're distributed, right? So we do the dynamic quorum system across multiple servers in the data center. All of our servers are sharing nothing. But the general idea is that when a write transaction comes in, we do a simple majority across the servers that have the shards that are required for this write transaction. And so we're basically looking, can we do a successful fsync on a simple majority of those servers? So will two servers reply back, yes, I fsync all as well, as HTTP API, so in that case we'll return a 201 created. If we can only do an fsync to one box, thereby not meeting the quorum requirement, we will return a 202 accepted HTTP error code, basically saying it's on a disk, it's not on the full quorum of the disk, but we got somewhere else in the system. Have your app react if it needs to. When you start involving disk, especially in the cloud, make sure it's fast, right? So one of the reasons why Mongo has such amazing write benchmarks is it's all going to RAM, right? They just screech, and then it runs out of RAM, and then the box falls over and it's dead. But if you look at us, we're just like constantly going like this, and that's just a nice thing that we got from Couch as well. But in order to maintain good IOPS for your database, we buy 15K RPM SAS drives, and those topped out at 600 gigs. And then we RAID them. A lot of eyes just glazed over. You guys probably haven't talked to data center people, but those drives are very expensive, but they're very fast. We'll eventually use SSD once it gets cheap enough. But you need to be careful when you go to AWS, Rackspace, whatever, Joint, whatever, because more often than not, those drives are not local to the box. That host machine that has your cloud server, virtual, whatever thing, it's doing communication to the hard drive probably across the data center floor. Joint is unique in that they actually put the drives local into the box. EC2 is unique in that they have the worst network out of any provider that I have ever seen. The latency goes like this, and then it goes away because you drop a link or whatever, and then it goes like this again. We've actually seen better network response and throughput from a customer sending communication out of EC2 and into another provider in Azure. Like, that's faster than trying to do AWS to AWS connectivity. It's crazy. So that impacts the request coming into the box, but then that also impacts your disk IOPS, right? Because if you're relying on the rotations per minute of a spindle or multiple spindles, it doesn't matter if it's 15K or 7.2, you have to go across this crazy-ass network. Also, we found out fairly recently that there was an ex-Amazon engineer who did a ask me whatever Reddit thing. I don't know, I'm not cool enough to use Reddit. I don't know what they call it. But you got to interview this anonymous AWS engineer on Reddit, and they basically said, "Hey, what's this whole reliable EBS thing? Is it real? Should I use it?" And the response was no. And the only way it's done, it's not like a special EBS installation. They're just flipping a quality of service bit on the datagram and sending that along, so that the routers give it priority in routing. Yay! But to finish this point, this is why. So we've got cloud in our name, but we don't actually use virtual. When you come and you use our service, you're landing on bare metal machines. And those bare metal machines are, they share nothing. They might be in the same rack, but if you're a cool enough customer with a checkbook, we'll make sure that they end up in different racks in the data center. Do effectively 2 to 2.4 terabytes per node because we store 3 replicas of every piece of data for every 3 nodes you add to get about 2 terabytes. And if you want to hear that again, let's do a sales call. So concurrent connections. This is my last slide. I kind of made this point earlier, but to really drive it home, concurrent connections are a problem. One of our favorite customer stories is Hothead Games. So they're a mobile game company based up in Vancouver. They've been building games that, they used to be EA employees, whatever. They worked on really big titles. And now they're just building mobile games. The problem with them and a lot of other game studios that we work with is that they are extremely good at optimizing rendering engines. They suck at optimizing web services. Right? This is something that you see it with every EA title that launches and then crashes, every big new MMO or whatever that launches and crashes. This is generally the problem that you're seeing. So they came to us about a year and a half ago, said, so we launched our game, we got featured by the iOS, Apple Store, whatever, and we crashed because they were running on some 3-server Postgres installation, and it just didn't work for them. So we ported it, and if you looked at their user graph, it was spiked way up here, and then it just crashed right back down, right? Those are users that they'll never get back again. Because if you've ever opened up a mobile app and it didn't respond to you, and you had full signal, you're never going to open that app ever again, probably. And if you're in the mobile game, you understand at a very precise level your cost to acquire a user and how much money you're going to make off of each one of those users over a given lifespan. So they could calculate very precisely just how much money they had lost in that day or a couple days. So they came to us, we ported them over onto Cloudant in about 2 weeks. No one really slept, right? We got them over, and they started on a 6-node cluster in one data center. Year later, their cluster size is approximately 230 servers spread across 2 data centers, both in North America. They've got an analytics cluster, and they've got another cluster for backups. And this is one to drive home that you want to scale horizontally. We learned when horizontal scaling became very easy with private server or virtual server technology. This is trivial to spin up a whole bunch of these things, and I want to scale horizontally now. You should be able to do that with your database as well. Not a lot of databases let you do that. Or they'll let you scale your slaves but not your masters because of that concurrency problem. or consistency, excuse me. The other point here is they came to us because we provided it as a service, right? We don't, yeah, we're a database company, but we're not a database company, right? We're as a service. This should just work. Consuming your database should be just like consuming your power bill or whatever else. You should be allowed to focus on your core competency. I guarantee I can pick out most of the people in this room, because I know I've got another cloud engineer here, whose core competency it is to build a scalable data layer as a service and basically be the CDN for your database. And that's a very, very hard problem to solve. Don't. Like, go build your app. Go focus on that core competency. And that's true if you're a startup. That's also true if you're a line of business in a big box organization. We're seeing more and more of these rogue dev units. There's one guy. He works at a large Boston financial institution. And he was building a new consumer-facing application for this institution. And he built everything on Node, by the way. And he said, all right, I now need a database. And he went to his guys. He tested like every database that was out there and knew exactly what he wanted. He went to IT and Ops, said, yeah, we can give that to you. Okay, great. When? 6 months. What? Like, no, not 6 months. And what if I need servers after that? Well, let's give you another 6 months. Well, this is crazy now. So this guy at a large financial institution was able to go out, consume Rackspace, consume EC2, consume Cloudant, consume all these different functions. And he was able to scale and get his app out on time. So that's the last kind of yay as a service comment. Thank you.
Before we move on to the QA, we are giving away an awesome bottle of champagne. In order to win this bottle of champagne, simply drop your business card in there. Look at someone's card. Whoever that is, I hope they win. Just drop your card in here. If you don't have a card, then just write your name on anything, and you may be able to win. Before we move on to the QA, please let's get a couple words in from the CTO of Patch.com, Andreas.
Thanks, everyone. Just make it quick. My name is Andreas Stransky. We're really glad that we could host our third Database Month meetup here. If you know people who are looking for meetups place, let me know. But otherwise, I'd let you get back to things. By the way, Patch.com's hyperlocal news site. We have editors around the country providing news, and we're a big scholar shop right here in New York.
Hey guys, what's it doing still here? Come on, pass it back. All the back. It's got to make it to the end of the room so everyone's got a chance to win this awesome bottle of champagne. While that's passing around, let's take the first question. Hands. Questions? Right there.
It's to the Node.js Cloudant. Do you guys host on your Node.js? There we go. Do you guys host in the app that has come out in Europe?
Yeah, so Nodejitsu, like one of our products is this platform as a service. So like we make it really easy to like get a Node.js application up and running. So you do like a Jitsu deploy and like it's up there. And we have data centers in like Amsterdam, like Virginia, Vegas, and a couple others.
Questions? Yes.
Are you familiar with Datomic?
What?
Datomic?
Datomic. I have looked at their website. I have never actually done anything with them.
They separated out. They've got vertical for writes, but horizontal for queries and storage.
Right, and so that's the whole. So that's the whole. The question was around Datomic, and they say that they can vertically scale your writes, horizontally scale your reads. Right, that's the entire point behind a master-slave architecture. Is it's great you can horizontally scale your reads by adding more servers, but you can still only have that one server, that one node, or whatever.
By partitioning that way, you can.
Right, so partitioning you can kind of horizontally scale, but at the end of the day, for a single piece of data, you still rely on one server, right? So for a given write, it's not horizontally scaled, right? So it's kind of like a bait and switch, and that's not a comment on data like this is a comment on master-slave architecture. With us, it's master-master, and so you can do a write to any server, and it'll be able to handle and coordinate, or any data center.
What's the minimum buy-in?
Minimum buy-in is your username and password that you put in cloudant.com. But yeah, so the first, things like the first 5 gigs or something like that are free, and then we start metering you. It's like $1 per gig and $1 per some amount of IOPS per month. But for companies like Hothead or Samsung or Runkeeper recently became a customer, those people are not using multi-tenant with 17,000 other people. Those people are on dedicated clusters, and that's per server per month pricing of M30.
Next question? Hands, questions? Okay. Sam and Jarrett will be here for one-on-one questions afterwards. Could someone please pass back that basket so we can give away some champagne? This. No, pass forward. We did that already. Everyone had a chance to get in? Ma'am, would you mind mixing it up? And once it's all mixed, close your eyes and reach in and grab one. Read it out loud. Libby Swan? Hi. Sit down. Libby Swan. Oh, boy. Is she here? Libby, come on up and grab some champagne. Okay, Sam and Jarrett will be here for one-on-one questions. Thank you all for coming.
Thank you.
That's right.